This is still our test 2 review. We're graphing trig functions. I'm going to try to just do these 4 on this video, and then for the next 4 we'll start a new video. So here we go, 17 through 20. I wrote several things in here already just to save us some time, so make sure you always put phase shift, period, amplitude, and vertical shift. So y equals 3 cosine of theta. The phase shift is 0 because there's nothing added here to theta. So that's a 0. The period is just regular 2 pi because there's nothing multiplied here times theta. So the normal period of cosine is 2 pi. That stays the same. The amplitude, that's going to be this 3 here. And there's nothing added out here. And so the vertical shift is 0. So we start with that. I already have an x-axis and a y-axis drawn in here. Sometimes I say don't draw the y-axis. I only say that when there is a phase shift, because then it's a little easier to put in the y-axis later. So no phase shift here, so we can draw the x-axis and y-axis. So what we do when we graph these is we know our starting point is at 0, and then we just pick a point down somewhere to put our end of our first period. That's 2 pi. Divide that in half. And this is easy division. 2 pi divided into halves is pi. Then this is half pi. Or you could put pi over 2, and this is 3 halves pi, 3 pi over 2. And then we're going to go back to negative pi over 2. Maybe back to negative pi. And then this one right here, we would go up another half. So this would be 2.5 or 5 pi over 2. Our amplitude is 3. So we need to go up to 3 and down to negative 3. We're graphing cosine here, so cosine starts up, kind of at our starting place, up at 3, down to 0, down to negative 3, back up to 0, back to positive 3, down to 0, coming over to the left, come down to 0, and down to negative 3 at negative pi, and then we just sketch our graph in there, going through those points, make them rounded at the ends. Ooh, don't do that. And there is our graph of y equals 3 cosine theta. Number 18. There is no phase shift because nothing's added to theta. So no phase shift. The period is different. So the period is the normal 2 pi. If you want to rewrite this, this is sine of 1/4 theta plus 1. And so we remember we do 2 pi. Sorry, this is going to be small, divided by 1/4. Well, dividing is the same as multiplying by the reciprocal. So that's 2 pi times 4 over 1, which is 8 pi. So our period is 8 pi. Amplitude is still just 1, and vertical shift is 1. No phase shift, so we can start here at 0. The period is 8 pi. That's much larger than normal. So I want to just make sure where we are aware of that, and I'm going to kind of go off our page here. But if the period is 8 pi, we'd really be a lot further out. Now, we get to mark our graph however we want, so we can fit it on the page. But I'm going to come way out here and say this is 8 pi, because our period was 8 pi. So half of that, so try to where half of that is, that's going to be 4 pi, 2 pi, and 6 pi. Now realize 2 pi, that's our normal period, so don't graph this, but our normal sine graph would kind of fit in this. Oops, that wasn't great either, but would fit in that spot. And so now with this one, the period's a lot longer. Our amplitude is just 1, so we can go up 1 and down 1, and we're going to graph this. So sine starts at 0, it's up to 1, back down to 0, to -1, back up to 0. We could put a 10 pi in here, and that would go back up to 1. We could put a -2 pi over here, and that would be down to -1. And so here's the graph. So remember, we graph this before we do our vertical shift, and then we will compensate for the vertical shift here in a minute. Forgot to write pi there. So there's our graph. And again, just as a reminder, our normal sine graph, we can see how spread out this thing is by realizing our normal sine graph would squeeze into this section. And so it would just it would be a lot smaller. Now, again, I'm going to undo that because we don't need that there. We still have to compensate for our vertical shift. So our graph right now, we have that horizontal line, which we call our x-axis, but we actually don't want that to be our x-axis. We want everything to move up 1. So what was the x-axis will now be 1. So I'm going to call this 1. This is my my y=1 line, which means my x-axis is 1 space below that. So here's my x-axis. So if you use your pencil or a pen and bold that to show that's actually your x-axis, which means this is 2. And so there is the graph of y equals sine of pi over 4 plus 1. All right, number 19. Let me put this thing here, but I'm actually going to change this a little bit. Okay, so this is cosecant. So remember, when we see a cosecant, we first graph y equals 3 sine of 2 theta, because those are reciprocals. So we're going to graph the y equals 3 sine of 2 theta, and then we will concern ourselves with the fact that it's cosecant. So we can start even just looking at this one. What's our phase shift? Well, the phase shift is 0. The period, all right, period is the normal 2 pi divided by this number, so divided by 2. So that was supposed to be a 2 under there. So 2 pi over 2 is just pi. The amplitude is 3, and there is no vertical shift. So what we want to do here is here's our starting point at 0. We're going to come over pi. Normally it's 2 pi, so I'm going to squeeze this in a little bit more than I normally do. So this is pi. Trouble with that, now I have to squeeze everything in that space. So we're going to split this into 4 equal parts. Half of pi is pi over 2. Half of pi over 2 is pi over 4. And then if we think I'm going to jump up by pi over 4 is pi over 4, 2 pi over 4, 3 pi over 4. So that's going to be 3 pi over 4. So we got another pi over 4 here. So that would be 5 pi over 4, 6 pi over 4. Well, that reduces to 3 pi over 2, 7 pi over 4. All right, so that should be enough for now. Go to negative pi over 4 here, and negative pi over 2. All right, so we're going to graph 3 sine of 2 theta. We did all that. There's our first period. I'll mark them bigger. Our amplitude is 3, so 1, 2, 3. 1, 2, 3. And for sine, we start at 0. Go up to 3, down to 0, down to -3, and we just keep that. Sometimes, I haven't done this a lot, but sometimes I'll put a dashed line here to help me have that lined up correctly. And so there, up to 3, 0. Coming back to the left of the y-axis. All right, so here is sine. Now this is, well, this is y equals 3 sine of 2 theta. Now remember, this graph I just graphed is not our answer. That is not our answer. We're using that to help us get our answer. So make sure you indicate in some way. You can make that dashed. You can make that dash to show that it's not the actual answer. It's because now what we want to do is we want to graph, so I'll do this in black. We want to graph 3 cosecant of 2 theta. So remember, when we have that, wherever this hits the midline, in this case the x-axis, we're going to put a vertical asymptote. And so we're going to put several vertical asymptotes in here. So I put in almost a full extra period on my graph. You don't need to do that. You do need at least one full period. So we put in those vertical asymptotes, and then we do the reciprocals, which ends up being this U shape and an upside down U. Remember, these hit the sine graph at the peaks and valleys. And so there is a graph, the graph of y equals 3 cosecant 2 theta. All right, coming to number 20, the last one here for this part of the video. We have secant. So as mentioned in number 19, we actually don't start by graphing secant. We want to graph y equals, and the reciprocal of secant is cosine. So cosine of theta plus, not plus, minus 2 pi over 3. And so we're going to put all this info for this cosine. So the phase shift is right 2 pi over 3. The period doesn't change. There's nothing multiplied out here, so this is just 2 pi. The amplitude doesn't change. It's 1, and there's no vertical shift. Now, I didn't put an x-axis in there yet because we're a y-axis. I guess I could have put the x-axis. So I'm going to put an x-axis in here, but I'm not going to put the y-axis in there yet because there is a phase shift. It's a little easier to do. So here we go. I don't know what I'm doing with my colors here. We'll stick with blue, I suppose. So we're going to just pick our starting place. And remember, our starting place is at 2 pi over 3. Our ending place, so I'm going to pick an ending place, and that is, I'll put it pretty far down here, but that distance is 2 pi. So we want to take 2 pi over 3 plus 2 pi to get our ending spot. Well, common denominator multiplied by 3 over 3. Sorry, 3 over 3. So it's 2 pi over 3 plus 6 pi over 3 is 8 pi over 3. So our ending spot is 8 pi over 3. All right, so we want to find halfway in between there. When the phase shift changes, these are the ones that take longer. They're not terribly hard. They're just more work and take up more room. So we want to find halfway between 2 and 8. And so we can add those together and divide by 2 to find the middle. So let's say middle is 2 pi. And I've done this a couple different ways. It's going to be over 3. So we can just find halfway between 2 and 8. So 2 pi plus 8 pi over 2 is 10 pi over 2, which is 5 pi. So this is 5. And then we want to find halfway between 2 and 5. So these are this is our quarter spot. So we take 2 pi plus 5 pi over 2. And this sometimes throws us off. This is 7 pi over 2, which is 3.5 pi. But really, this is 7 pi over 2 over 3. Dividing is the same as multiplying by the reciprocal. So that's 7 pi over 2 times 3. Times 1/3. The reciprocal of 3 gives us 7 pi over 6. So this is 7 pi over 6. And then our last one, we need to find halfway between 5 pi over 3 and 8 pi over 3. Sorry, we've not been throwing in the 3 there yet. So halfway between 5 and 8 over 2 is 13 pi over 2. But now we want to take that, that's thirds. So dividing is the same as multiplying by the reciprocal, so we get 13 pi over 6. Now, just to remind you, I mentioned this, don't get hung up on there if you're really having trouble, which I hope you're not with fractions. Yes, they take a little longer, but they're still doable. Don't just think through the process, think through what you're trying to do. You're just trying to find halfway between a couple points. But if you're only able to find this, keep going, keep graphing. Don't just stop because you're having trouble finding fractions. Even if you had trouble finding that fraction, don't stop. Still draw the graph. So anyway, that's that. So we are graphing y equals cosine. So this is not our y-axis, so I'll make it a dashed line. This is just our starting spot. So our amplitude is 1, so we can go up to 1, down to -1. So here is cosine. So we have, I'm just going to do this dash because I'm thinking ahead and realizing I actually don't want the graph of cosine is not my answer. It's just used to help me get my answer. So I'm going to make that dashed. So wherever, so now let's change to black. I don't want this dashed line to mess us up. That is not one of our asymptotes. So I'm going to change to a different color. So black is going to be the ones that represent the asymptotes that we want. I'm trying to make them a little bolder. So asymptotes, vertical asymptotes go wherever our cosine graph crossed the x-axis. And then we can graph. All right, so that black is the graph of secant theta minus 2 pi over 3. It would be good to get our y-axis in here. I'm trying to look for something in my work here. So here's, well, that's not what I want. 7 pi over 2. That was our halfway point. That gave us 7 pi over 6. So this is 2 pi over 3. Let's think of it this way. From here to here is 3 pi over 3. So if we went 3 pi over 3 this way, so we're at 2 pi over 3. 3 pi over 3 this way would be negative pi over 3, which means our y-axis would be about right here. Just for reference. All right, so there is the graph of y equals secant theta minus 2 pi over 3.